Okay, so you can imagine for a person like myself that talking about alternative energy, especially renewable alternative energy, gets really exciting. Moving away from fossil fuels as a topic, whew, great relief. But there's this one thing that over the years I've noticed a lot of students struggle with. And so I need to put a little band-aid over a weakness in our science education. There's like a little thing that's really important for you to see conceptually. So I've got a little demo coming up and I hope it'll work. I've never done this demo in the man cave using Zoom. But I want to explain how turbines generate electricity. Because almost everything that we're going to discuss as a form of electricity will one way or another spin a turbine to make electricity. There's this thing called induction, where a magnet moves past a wire and makes current. Remember that current is excitement in neighboring atoms. So there's one atom, and when you make it excited, it'll have an electron that goes to an elevated energy state, and eventually gravity will pull that electron back, and so all that leftover excitement energy has to be passed to a neighboring atom, which will get excited when it takes that energy, and then that energy's sort of passed. That's called current. This is what we mean by electricity. We will always say moving electrons. It's super common, but technically the electrons don't leave at one end. It's not like your battery is running out of electrons. Technically, there's this like excitement passing thing called current. So when you pass a magnet next to a wire, it makes a surge of current go through that wire. There's this thing called the left-hand rule of induction, right-hand rule, left-hand rule. You'll take physics someday. And if you have a whole bunch of wires, every time a magnetic field passes next to a wire, you're going to put current in that wire. So get ready for this shift. I know some of you get distracted. My videos are rambling, but watch this. See those four little arrows? If you have a coil of wire, you're just going to put 4 hits of current into that one wire. So now that wire has more current. So if you were to take apart an electric generator or an electric motor inside of a fan, you would see a bundle of wires and you would see a handful of magnets. And basically, almost every type of electricity, like if you're generating electricity, there's like an exception. Otherwise, all the electricity on Earth is finding a way to spin magnets along wires. I got a demo. I'm so nervous. God, I hope this works. I don't have time to do this class twice. I really hope this works. I gathered some junk. This is a bunch of copper wire. That is an LED, a light emitting diode. And in the middle is a square magnet that's attached to a nail. So look, I'm spinning a magnet. I got a bad feeling about this. Okay, here's me. I got to find something that's dark. I don't know if you can see that because now my screen is too bright. How do I do this? All right. This is going to be maximum awkward. Let's see if this works. I won't know if that worked. What's crazy is I'll never know if that worked. I got no idea because I had to turn off my monitor, so I didn't see if that was recorded. Well, that's a little bit nerve-wracking. If it worked, you should have seen these little blue blips. I doubt my camera worked in the dark. I have a bad feeling. Anyway, this thing makes little blue blips. It was a good demo in my other classes, I swear. Those blue blips are electricity traveling through the light emitting diode. And every type of power plant on Earth, with one very small exception, is just finding a way to spin a turbine. You're just trying to get, turbine is the thing that powers the motor spinning in the magnet spinning in the wires. So like you can use flowing water to spin a thing that spins a thing, that magnet and wire, or you can heat up water and make steam and that's gonna, or you can use wind, or you can ride a bicycle to spin a turbine, but one way or another, that's spinning magnets past wires, magnets past wires, magnets past wires, magnet past a wire. Hey, that thing is just a way to spin magnet past a wire, and thank God we trapped all that water because you can let it out and spin a magnet past a wire. There you have the steam going in, steam coming out. You can see all the magnetic fields, all the wires, electricity leaving, and I'm not really good at art. This is all complicated. There's a bunch of engineering that goes into this, but whenever I have to explain this during class, I'll just use this, which is my version of a turbine. Some kind of force is going to spin those blades, and inside of that tube, a magnet will move past wires and put a whole bunch of current into that wire. You can see we call that electricity. That's the E leaving my turbine drawing. And that's why I do these ugly drawings. That's a turbine. Key concept is over. That's how a turbine works. I really hope that worked. God, I have no idea.